welcome back to our IGCSE Mathematics past paper walkthrough. I'm Hayan and I will be your video host for today. Varshini will be our amazing contributor who will explain and guide you through the paper Winter 2022, paper 41. So are you ready? Let's get started.
Hi everyone. So as Hayan said, we'll be going through paper 4.1 of October-November. So this is the first question, as you can see. 1A, calculate the volume of, firstly, a solid cylinder with radius 6 centimeters and height 4 centimeters. Okay, so firstly, we know that the formula to calculate the volume of a cylinder is just pi r squared h. Okay. So now we just need to substitute in our values. We know the radius is 6 and the height is 14. So that is going to become pi into 6 squared into 14. And now, if you just put this straight into your calculator, you should get 1583 equals 1583. And remember, we always need to round it to just three significant figures. So we're just going to make this 1580 and round the 3 down. Okay, part 2, a solid hemisphere with radius 6 centimeters. And they've also told us that the volume of a sphere is 4 by 3 pi r cubed over here. But remember, we want a hemisphere, not a whole sphere. So that's just half the sphere. So that means we're going to divide the volume of the sphere by 2. So that's going to become 4 by 3. Hold on. Yeah, that's going to become 4 by 3 pi r cubed into 1 by 2. Okay, and we can just cancel this 2 out as 4 goes, or we can just leave the expression like this. And now we just again need to substitute in our values, and here we have the radius is 6. So it's going to be 4 by 3 into pi into 6 cubed into 1 by 2. So again, you just need to put that straight into your calculator, 4 by 3. And remember, use the pi button. Don't use the calculated value of pi, because that'll give you the value to all the decimal places that you need. So now you should get 452.38 equals 452.3.4, let's say. My bad. 0.4. And again, we're going to round it to 3 significant figures. So the 4 is going to round down. So that's going to become 452 centimeters. Okay. Now, part B, the cylinder and hemisphere in part A that we just calculated the volume of are joined to form the solid in the diagram. The solid is 7.85 grams. And show that 1 centimeter cubed of steel has a mass of 0.00785 kgs. Okay, so firstly, we can see that these two units are in two different units, 7.85 grams and 0.0075. So let's convert the grams to kgs. We know that 1 gram. No, let's say this the other way around. We know that 1 kg equals 1,000 grams. And so it follows that we just need to divide both sides by 1,000 to find the mass. So we can also say that 1 gram equals 1 by 1,000 kgs. So now to find the kgs of 7.85, we're just going to divide it by 1,000. So if you just put that in your calculator, 7.85 divided by 1,000. Okay, because we want 7.85 grams, not 1 gram. So that is going to give us 0.00, sorry, 0.00785. Okay, so now we also know over here that they want us to find the mass, and we do know that density the density. So we over here they've said density 185 kgs. Let's write that down. 1 centimeter cubed equals 0.00785 kgs. And now we want to find for how many ever centimeter cubed we've calculated the volume to be, how many kgs is that? Okay, so we do know our total volume is going to be the volume of our cylinder plus the volume of our hemisphere. Total volume is going to be, so now just add those two numbers up in your calculator. Don't do anything like manually because you can make mistakes easily. So 452 plus 1583, and you should get 2035. 35. And remember, use don't use the rounded off values. I kind of rounded off my values a little bit, but when you're calculating, make sure you use the exact values, because otherwise your answer could be slightly different than the one they want. Okay, so now that we have the total volume, and remember this is in centimeter cubed. Okay, we want to find how many kgs this is. Let's put many kgs. So now we can easily just cross multiply these two numbers in our calculator, 0.00785 into 2035. And you should get 15.97. Now, we're just going to round off to three significant figures, but over here, since the 9 is going to round up, become 10, which is just 0, and a 6 in the units place. That's going to be 16.0. And don't forget the 0.0 to show that you are including three significant figures and not just two. Okay, and some of it is used to make 50 spheres with radius 2 centimeters. So let's see the radius of our sphere. Okay, so our sphere isn't related, so this is a separate problem. So 2,000 centimeter cubed of iron is melted down, and some of it is used to make 50 spheres with radius 2 centimeters. Substitute that in. So 4 by 3 pi, hold on, it's wonky, pi, and r over here is going to be 2 cubed. And remember, this would be for one sphere, but we want 50, so we're going to multiply this into 50. And now, if you put that in your calculator, 4 by 3, and remember again, use the exact value of pi, q cubed into 50, you should get 1675.5. Put something, but we're just gonna leave it at 1 decimal place, which should be. So now we're gonna just find that value by doing 2000 minus in your calculator. You should get 324.5. 324.5. Or the percentage of iron that's left over. For the percentage formula, it's just part by whole um, 324.5 divided by the whole, remember, which is going to be 2000 over here, because that's the entire value that we had, by 2000 into 100. So now again, just put this in your calculator into 100, and you should get 16.2%. To 16.2. Okay. Draw graph. Have equal sides. So this is going to be x, this is going to be x, and this is also going to be x. Volume cube is going to be nothing but x cubed, and x being the side length, the edge length. So this being an edge, as they're all the same size. So we know, so cubed, as we've said over here. So 324.5 is equal to x cubed. We can say that because that's going to be the volume made into cube and the sides. So 324 to get rid of the cube equals, and I'm going to put a huge cube root over this. And remember, don't forget to put the 3 over here, and don't make it a square root. That'll give you the incorrect value. Okay, so that should give you 6.87. 6.871. 87 or something similar, and we're going to round that off to 3 significant figures again, so 6.87. Okay, question 1D. A solid cone has radius 3r centimeters, and slant height 9r centimeters. So just visualize that. Let's draw the cone. So they're saying the radius is, so this much is 3r, and the slant height is 9r. My bad. 9r. The solid cylinder has radius x centimeters and height 7x. So that's the cylinder. My 7x, and the radius is x. So now the total surface area of the cone is equal to the total surface area of the cylinder. So okay, so we can equate the two equations we make. So given that r equals kx, find the value of k. So let's not worry about the last part for now. Uh, let's find the area of the surface areas in terms of r and x's, and then equate them. Okay, so first, we know that they've given us curved surface area of a cone. Okay, or the curved surface area, not the total surface area. So the curved surface area of a cone is equal to 9x. Okay, so we know that is equal to pi r into L. Okay, so over here, let's substitute in our value of r and our value of L. The value of r is 3r, and L, but remember that's just the curved surface area. We haven't included this in our calculation, but we know the base is just going to look like a circle, and we know the base is just going to look like a circle, and we know the area for the circle is just pi r squared. So we can just do this plus pi r squared, and remember in terms of r. Okay, so plus pi, and over here r would be 3r, because that's the radius of the whole thing. Okay, uh, 3r. Remember, the whole thing is getting squared, not just the r, because the radius is 3r, not r. Okay, so now we have the surface area of the cone. Okay, now we need to equate this to the total surface area of the cylinder. So we're going to put an equal to sign, and now we're going to write the surface area of the cylinder in terms of x. Okay, so we know that for a cylinder, the curved surface area around this part, like basically this entire part, excluding this base and this base, okay, is just going to be 2 pi r h. Okay, 2 pi r h. If you're confused, you can always think about this as the circumference of the circle. Let's look at the circle. Circumference of the circle into the height, which is x. So it's x. Wait. XH. Okay, and remember that's not the total surface area. The total surface area includes this top base and this bottom base of the cylinder. Okay, so and those are just again going to be two circles. Okay, and the circles we know to have a radius of x. Okay, so that's going to be plus pi x squared. Okay, and remember, this is coming 2 times. So pi x squared into 2 pi x squared, we can think of it. Okay, so now that we have equated the surface areas, we can simplify them a little bit. So firstly, let's take this term, pi into 3r into 9r. So since 3r and 9r are both r's, we know that we can just instead represent this as r squared, and we also know that we can just multiply out 3 into 9. Okay, so 3 into 9 is 27, and r into r is r squared. So that's going to give us 27 pi, don't forget the pi r squared. Yeah. Plus, now let's simplify the second term. 3r is getting squared, so that means we have to square both the 3 and the r. So and we know 3 squared is 9, and r squared is just r squared. So that's going to be 9 pi r squared equals, and now we have this whole value, 2 pi x h plus pi x squared plus 2 pi x squared, remember, because it's being multiplied into 2. Okay, so now we also know that we can see pi over here in every term. So before we move forward, we know since it's in every term, because it's in every term, we can cancel it out. Because again, if we were to rewrite these equation, we could factor pi out of this side and one side as well, and then we could just divide both sides by pi, and it would just go. So since they're we can just cancel out these pi's to make our equation less confusing. Okay, and over here we also have x, which we know is 7x. So I forgot to represent this term. So this is going to become 2 into x into h, which you did see is 7x. It says over here the height is 7x. And we know, okay, so into 7x. And we know, again, we can just multiply these. X into x is going to be x squared, and 2 into 7 is 14. So that's just going to be 14x squared. Okay, so we can cancel out this term, and we just left us 14x squared. Okay, so now we can also see that these terms are similar, 27r squared plus 9r squared. So for example, if we were adding x terms, 27x plus 9x, we would get 36x. So in the same way, 27r squared plus 9r squared is going to give us 36r squared. We don't have to multiply the r's or add the r's. Just think of r squared as one term like x. So that's just going to be 27 plus 9 is 36. That's going to be 36r squared. Remember, we've canceled out the pi's. Okay, equals, now let's find this side of the equation, the right side of the equation. So again, we have two similar terms, 14x squared and 2x squared. So thinking of x squared as a term like 2x plus 14x, I mean, maybe not x, but like 2y plus 14y, that would just give us 16y, because we're just adding the two terms since they have the same coefficient. Since not the same coefficient, they have the same variable. So since again x squared and x squared is the same variable, so we can add 2 to 14. That'll give us 16x squared. So now that we just have one term on each side of the equation, remember they want us to find r. Let's read this part again. R equals kx, and they want us to find the value of k. So we have to, as we can see from r equals kx, we need to make r on one side of the equation. Okay, so that means we're gonna have to take away 36 and get rid of the squared on the r. Okay, so first let's divide both sides by 36 to get rid of this 36. Okay, so we're going to divide both sides by 36. And now we're left with r squared equals 16x squared by 36. Okay, remember, again, we want r, not r squared. And to get rid of a square, we always just square root both sides. So that is going to give us, right over here, r is equal to the square root of 16x squared divided by 36. Okay, so now let me clear up some stuff. Hold on. Okay. And remember, in your exam, don't wipe or clear away anything, because the examiner needs to see all your working. You can always ask for an extra page if you need one. Okay, so now we have r equals the root of 16x squared by 36. And we also know that for any fraction, if we take the root of, let's say, x by y, that's just going to give us the root of x by the root of y. So in the same way, that's just r is just going to be equal to the root of 16x squared divided by the root of 36. And again, from this top part, since it has two things in it, we also know that. Okay, yeah, we also know that for a fraction, the root of xy is just going to be the root of x into the root of y. Okay, and so this over here, root of 16x squared is going to be the root of 16 into the root of x. And if you put that in your calculator, or like as we do know, the root of 16 is just 4. And the root of x squared, we know is just going to be x, because that's even how we get rid of square roots. We just take the root of them. Okay, so now we're going to divide that by root of 36. And takes that. We know that the root of 36, or if you could just put in your calculator, it's going to be 6. Okay, so now if we simplify this fraction, divide both the numerator and the denominator by 2, or you could just put 4 by 6 in your calculator, and you guys see if it's a bigger number, and see what the fraction the calculator gives you. And in this case, it's 2 by 3. And again, we know x squared, root of x squared is going to become x. So now let's read the question again. So we have, given that r equals kx, we have that over here. R is equal to 2 by 3x. Find the value of k. So k is just over here, as we can see the number before x. And here, that's just going to be 2 by 3. K is equal to 2 by 3. Okay. For the next question, part 2a. So firstly, we have write 2994.99 correct to the nearest 10. Okay, so for the 10, all we have to do is look at the 10's place here, 9, and the 1's place, 4. 10 and the place right before that. Okay, so we know that over here 4 is smaller than 5. Okay, so that means we can leave 9 as 9. Okay, if it was bigger than 5, we'd have to round 9 up. But since it's smaller, since 4 is smaller than 5, lesser than 5, we just leave this as it is, and we only need to write it in till the 10. Okay, so that's just going to be 2990. Okay, and why are we writing 0? That means, see, if 4, sorry, I meant round it down. So if 4, since 4 is smaller than 5, you turn it into a 0, and if it's greater than 5, then you turn 9 into the next number. Okay, so now we have 2990. Now for our next one, we can ignore the decimals, okay, for this. 0.983 correct to 1 decimal place, okay? So now what's the place we're looking at? This place. And remember, we also have to look at the place before it. So that would be this place as well. So over here, we can see 8 is clearly greater than 5. Okay, so that means we have to round it up, okay, and increase 9 by 1. And we know if we increase 0.9 by 1, we should only get 1. Okay, so that means it's going to carry over to this, the units place, and it's going to be 0. And we can ignore the rest of the decimals because it just says correct to 1 decimal place. Okay, so it's 1.0. Now we have 2090 correct 2 significant figures. So what are 2 significant figures? In the case of a big number like this, each number here we can see is a significant figure, except for the 0 at the end, which is, according to the rules of significant figures, not a significant figure. So this over here, correct, right now we can see it's clearly in 3 significant figures, 209. Okay, but we want it to 2 significant figures, which means we again, for 2090, we only look at the 0 and of course the number before it, the 9. So again, as we can see, 9 is clearly greater than 5. So we're going to round the next number 0. We're going to round that up and make it 1. It's going to be 2100. And since it's only two significant figures, we're going to ignore the rest and not leave 9 out of it. Okay, so that's going to be 2100. Okay. B, write down a prime number between 90 and 100. Okay, so if you don't have prime numbers memorized between 90 and 100, which is completely fine, we just need to do this logically. So let's take all the numbers, 90, and again, they said between 90 and 100, so we're going to ignore 90 and 100 themselves, even though we do know that they're obviously not prime numbers because they both have zeros. And if it has 0, that means it's divisible by 10, which means it's not a prime number. If let's just recount our definition of a prime number. It's only divisible by itself and 1. Okay, so now let's write down the numbers between 1900. That's going to be 91, 92, 93, 94, 96, 97, 98, and 99. Okay, so firstly, let's look at 91. We're just going to divide it by numbers that like like smaller prime numbers that we know. So you obviously know 91 isn't divisible by 2 or 5, but if you divide it by 7, it gives you 13. So we know that's out. Um, 92 is obviously divisible by 2 because it has a 2's in the second place. We can move on. 93 is also divisible by 3. You know this because 3 is 9 and 3 are both divisible by 3. And also 9 plus 3 will also be divisible by 3. So that's not the option. 94, again, it has an even number in the ones place, so we know that's not divisible. So that is divisible by 2 and not just by 1 in itself. Okay, so that's obviously not the option. 96, oh wait, sorry, I missed out 95. 95. And we know, of course, 95 isn't divisible because anything with 5 or 0 is divisible by 5. So we can take that out. Take all of these out. 96 again has an even number in its ones place, so no. And 97 over here, it doesn't have anything in its, we can try to divide it by prime numbers. 97 by 7, no, you put in your calculator, it gives you a decimal. 97 divided by just put in random numbers. 13, no, it doesn't give you. 97 divided by 11, no, you get a bunch of decimals. And if you're not sure, and so the number is 97, we can write it here. But if you're not sure, you can always reason out. 98 we also know is not divisible because it has, again, an even number in its ones place, so no. And 99, of course, again, 9 and 9 are both divisible by 3, so it's not. So even by just eliminating the rest, we know it's 97. Okay, part C, write 2 to the power negative 6 as a fraction. Okay, so we know that when there's x to the power negative y, okay, that's just equal to 1 by x to the power y. So we can write that, so 2 to the power, and so therefore 2 to the power negative 6 is going to be 1 by 2 to the power 6. 2 to the power 6, yeah. Okay, so now what is 2 to the power 6? We have a calculator, so we can just put that in our calculator. We should get 64. Okay, so the answer is going to be 1 by 64. We can just write that over here. Okay, part D. Write 0.00701 in standard form. So what is standard form? It's when it's something, let's say 1, oh my god, 1 point, let's say 2 or something like this, times 10 to the power x, where x is just, let's, maybe in this case it could be times 10 to the power 10. So basically there has to be, it has to be 1 point, like there can only be 1 over here in this area, 1.2. It can't be 12 into 10 to the power 7. It has to be 1.2 or 1.0 or 1, okay, into whatever to the power whatever. Okay, so in this case they've given us 0.00701. So to find out how many times that has gone in 10, okay, we can just look at where the decimal point is. So it's over here. So, and remember, we want it to look like 7.01 into 10 to the power something. Okay, so we're just going to move the decimal point backwards until it's right after 7. So that's over here, 1, 2, 3. And since we moved it 3 times backwards, okay, that's going to be 10 to the power negative 3. Okay, but if we had let's say if we had 700, and the decimal point is over here. And again, we want to move it to 7, again in front of 7. We're going to move it 1, 2. And since we're moving it forward, that would be times 10 to the power 2. But since it's backward, this is going to be 10 to the power negative 3. And so now we can just write this 7.01 to 10 to the power negative 3. Okay, the next question. Simplify 1.5 into 10 to the power x. Just add the brackets here to not confuse ourselves. Oh, my bad. Yeah. Plus 1.5 into 10 to the power x minus 1. Give your answer in standard form. So firstly, we know that for numbers in standard form, we can if we want to add them up, let's say 2 into 10 to the power x plus 3 into 10 to the power x. Only if these two numbers are the same, 10 to the power x and this 10 to the power x, we can add 2 and 3 and make this 5 times 10 to the power x. Okay, but however, if they're not the same, like in this case, where it says x, let's say let's make this instead of 2 times 10 to the power x. Let's say it was 2 times 10 to the power 5 and 3 times 10 to the power 4. Sorry, 10 to the power 4. How would we add these? First, we make them both in. We have to make the powers the same of 10. So we make them both in 10 to the power 4. And since that means, what does that mean? For 2 times 10 to the power 5, if we're making, so it would originally be 1, 2, 3, 4, 5. But now we're saying it's 2, 1, 2, 3, 4. So that means we just need to add a 0 at the front, and this would become 20 into 10 to the power 4. Okay, so now we know what to do. Let's take the same case over here, these two numbers. So we need, of course, the rule is that we always express them in terms of the smaller power. So over here, x minus 1 is obviously smaller than x. So that means we need to express both of these numbers in terms of x to the power minus 1. Then we can just add the numbers. Okay, so how would we express them in x to the power minus 1? As we did with 2, so we already have 1.5. Hold on, 1.5 into 10 to the power x minus 1. Minus 1. And now we also have now to make 1.5 into 10 to the power x minus 1 instead of just x. Again, remember, we're going to add a 0 to 1.5. So, and that also means the same thing as moving the decimal point. Or we can also say multiplying 1.5 into 10, which will give us 15. So now we have 1.5 now we have 1.5 into 10 to the power x minus 1 plus 15 into 10 to the power x minus 1. So now we can add 1.5 and 15, and that'll give you 16.5. You have 16.5 into 10 to the power x minus 1. Oh, my bad. There's a point over here, not a multiplication sign. So that will just be 16.5 into 10 to the power x minus 1. But no, remember, in standard form, we can only have one number in front of the decimal point. So how do we make this 1.65? Again, if we're dividing by a 0, over here, x minus 1 has to increase by 1. The same way that when we subtracted 1 to make 1.515, we multiplied by 0. Okay, so that is going to be 1.65 into 10 to the power x. Okay, part F, write 0.37, and you can see 7 bar over here. It's a recurring decimal. As a fraction, you must show all your working. All right, so the rule is to write these as a fraction. Okay, first, we take 0.37 as equal to x. Okay, and now what we want to do is, firstly, we want to get the non-recurring numbers on one side of the decimal place versus the recurring numbers. Then we want to get both decimal numbers on one side of the recurring place. Okay, so what is that going to be? So firstly, we want 3.7. Okay, So we know if 0.7 is x, 3.7 is going to be, again, like when you move the decimal place, you multiply into 10. So that's just going to be, sorry, my bad, 3.7 equals 10x. Or you could just say we're multiplying 0.37 into 10, which is going to give us 10x, okay? And we also want, bar, this is a bar over here. And we also want, remember, we want just 7 on one side of the fraction. So to get 37.7, what is that going to be? We're going to multiply 0.37 into 100. So then it'll become 100x. Okay, now that we have these, let's rewrite it with this one at the top. Okay, so put this down the bottom. 3.7 equals 10x. Okay, so now that we have these, and remember there's a bar over here and a bar over here. Sorry, I forgot. Now, we're just gonna have to subtract. Okay, now the step is subtract. Okay, so 100x minus 10x. We know that that's just 100 minus 10, which is 90x. Okay, is going to be equal to, now see, when we're subtracting, if we subtract a recurring number from the same recurring number, we're going to get 0. Okay, so that means 7 bar minus 7 bar is just going to be 0. And now 37 minus 3 is nothing but 34. Okay, so now what we need to do is just find x. To find x, of course, we just have to divide both sides by 90. It'll just give us 34 by 90. And if you put that, and of course, don't put in your calculator to find the decimal, because I'll just give you the recurring decimal, okay? But do put in your calculator to find the simplified fraction, okay? So if you put 34 by 90 in your calculator, you should get the simplified fraction to be 17 by 45. And that is our answer over here. Yes, okay. Or, of course, we could just leave it as 34 by 90, because they haven't explicitly said a simplified fraction. But, okay, this also works. Okay, 3a, they've given us a number line, and they've said from -2 to 4, and they said write down the inequality shown by the number line. Okay, so we know that when there's a circle, that means that they're not including that number. It's empty, as in the number isn't being included. And when there's a shaded circle, whenever it's shaded or a full line, that number is being included. So if we took, so we know x is going to be between these two values, okay? So that means that x is, of course, greater than, is greater than -2. And why do we know x is greater than -2? Because if it is greater than equal to, it would be shaded. But no, it's not shaded, so it's not greater than equal to. And we also know that x is smaller than, and of course smaller than equal to, because 4 is shaded. So it means 4 is included x. So yeah, this is just the answer. -2 smaller than x smaller. And don't forget the -2, okay? Part B, solve the inequality. So they're giving us an inequality. So to do this, we can write this as two separate inequalities. One will be, one sec. One will be -3 smaller than equal to 2x, and the other one, 2x plus 3, and the other one will be 2x plus 3. We also know is going to be smaller than 9. So we've just split up this and this into two separate things. Okay, so now that we have both of these, let's just solve them separately. So firstly, for -3 smaller than equal to 2x plus 3, we just need to make x the subject of the formula for both of them. Okay, so how do we do this? First, let's subtract 3 from both sides to get rid of this 3. Okay, so, and if you subtract 3 from the other side, that's -3 minus 3, which is going to be -6. So we have -6 smaller than equal to 2x. And now, of course, we just need to divide both sides by 2. Okay, so we can just get rid of this 2 by dividing it. That'll just give us -3 smaller than equal to x. And now the other side, 2x plus 3 is smaller than 9. Okay, as we've written over here. Now again, let's get rid of the 3 by subtracting 3 from both sides. It's going to be 2x smaller than 9 minus 3, which is just 6. Okay, now to get rid of the 2, again, we're just going to divide both sides by 2. And x smaller than 6 by 2, if you put this in your calculator, it'll give you 3. 9, 2. Okay, yeah. Okay, so now that we have these two of x, we know x smaller than 3 and also x as we've written greater than equal to minus 3. Now how do we combine these into one? Now that we have these two values of x, okay, we can just we know that x is greater than minus 3 and x is smaller than 3. So we can write it in the same way as this top equation and say that x is smaller than hold on. Minus 3, x is greater than equal to minus 3. Sorry, x. And x is also, sorry, my bad. X is greater than equal to minus 3. And x is also smaller than 3, as we've written over here. So we just combined it into one. Let's give us minus 3 equal to x smaller than 3. Okay, so now write down all the integer values of x that satisfy the equation. So we know that for integer, it's not decimal, it's just the whole number values. Okay, so we also know that over here, it says x is greater than equal to minus 3. So that means minus 3 is included and minus 3 will be an integer value. We can start from minus 3 and we'll just go upwards from there. Minus 2, minus 1, 0, 1, 2. And now is 3 included? No, it's not included because it says it's smaller than 3, it's not equal to 3. So now these will just be our values. And first, remember the values in between minus 3 and 3. You can just write that again in the blank. Okay, part C, solve the equations. So firstly, they've given us 3 into 3 minus x minus 2 into x plus 2 by 5 equals 1. So we can see there's a fraction on the side of the equation. So to get rid of the fraction, what we have to do is make this term also into a fraction. Okay? Or alternatively, what we could do is just multiply all terms by 5 to get rid of the fraction. So to do that first, let's just multiply each of these terms by 5. Okay, so that's going to be 3 into 5 into 3 minus x. That's one whole term. Okay, remember, like each multiplication thing is a term. Okay, minus 2x plus 2. Okay, that's one term. And we multiply that by 5 to get rid of the 5 in the denominator. Okay, and now we're going to say that equals, we have to do 1 into 5, which is just 5. Okay, so now that we have these terms, all we need to do is get rid of the brackets and expand them. Okay, so that means we're going to multiply each term outside the bracket inside the bracket. Okay, so and 3 into 5 is, we also know, is 15. Okay, so first let's do 15 into 3. Okay, we know 15 into 3 is 45. And then 15 into minus x will just give us minus 15x. Okay, so now that we have that term expanded, we're going to expand this term. Okay, so minus 2 into x and minus 2 into 2. Okay, so that is going to give it minus 2, and don't forget the minus 2 over here. It's not just plus 2, it's minus 2. Okay, so minus 2 into x is going to give us minus 2x. And we also know minus 2 into 2 is going to give us minus 4. And we know this whole thing is equal to 5. Okay, so now to get x on one side of the equation, over here we can add the x terms as they both have, and we can also add the non-x terms, minus 4 and 45. Okay, so wait one sec, I'm doing something wrong. Um, am I? Oh wait, no. Wait, no, I'm not doing something wrong. My bad. Okay, wait. Wait. Can I just leave off from there?
Yeah.
So now that we have this, okay, so now we're going to just multiply out these brackets, get rid of them. So that's 15 into 3 is going, and we also have to do 15 into minus x. And we also do, hold on, my bad. Wait, I'm just redoing that part. Okay. Yeah, okay. So now that we have this equation, we just need to simplify the terms a little bit. So let's multiply out the brackets. We know that to multiply this out, we have to do 15 into 3 plus 15 into minus x. Okay, so 15 into 3 is going to give us 45. And 15 into minus x is going to give us minus 15x. And now we have to multiply out these brackets. Don't forget, it's a minus 2, not just a 2. So we're going to do minus 2 into x plus minus 2 into 2. So minus 2 into x is going to be minus 2x, of course. And minus 2 into 2 will be minus 4. And this equals 5, remember? Okay, so now we have, oh my god, we have two like terms over here. The x terms and the non-x terms, which we can add them up. So we know that minus 15x minus 2x will just be minus 15 minus 2 into x. So that's just minus 17x. So yeah, minus 17x. Now we know 45 minus 4 is 41. Now, of course, we just need to make x the subject of the formula. So we're going to get rid of 41 by subtracting it from both sides. We're going to get rid of 17. So now we just have 17. X is equal to 5 minus 41. So now we just have to divide both sides by minus 17. And if you put this in your calculator, you should get 36 by 17. So x equals 36 by 17, and we leave it as a fraction. Okay, part 2 of 5 by x plus 3 equals 3 by x plus 5. Okay, so how do we do this? We know whenever there's an equal to sign, we can always cross multiply. Multiply these two, and equate. So we basically what we have to do is equate x plus 3 into 3 is equal to 5 into x plus 5. So let's just write that. So that's going to be x plus 3 into 3 equals x plus 5 into 5. Now again, we just have to multiply out the brackets. So we have to do 3 into 3 and 3 into x. And in this case, 5 into 5 and 5 into x. So 3 into x is, of course, 3x. And 3 into 3 is 9. So we have to add these, remember? Okay, plus 9 is equal to 5 into x plus 5 into 5. So 5 into x is, of course, 5x. And 5 into 5 is 25. Now let's arrange all the x terms on one side of the equation. So let's take 5x to the opposite side. So since it's positive, we're trying to subtract it from both sides. So to get rid of 5x, it's going to be 3x minus 5x. Now let's also move the 9 to the other side. So subtract it essentially from both sides of the equation. And that's going to be 25 minus 9. And we know 3x minus 5x is also going to be 3 minus 5, which is just minus 2x, is equal to 16. Now again, to get rid of the minus 2, we divide both sides by minus 2. We get x is equal to minus 8. Okay. Question 4, part 1. Zach invests $500 at a rate of 2% per year simple interest. Calculate the value of Zach's investment at the end of 5 years. Okay, so we know that the formula in simple interest is for like whatever amount you have, whatever's the investment. Let's say I. Okay, I mean, not the whole investment, but the interest, let's say, simple interest, is going to be equal to whatever you've invested, so that's the principal, into the rate, okay, at which you're gaining interest, let's say R, into the time period in years, or like how often, like every 5 years or every like, whatever, okay? And this says 2% per year, so we know everything's in terms of years. Okay, so now then we do that by 100. So now all we have to do is substitute everything in the formula. Okay, so what he's investing is $500, and he's doing it at 2%, which not 2%, not 2 by 100, just 2, because R will just be in terms of percent. Okay, into the time, which is 5 years, divided by 100. Okay, so now whatever we get over here, which is 50, okay, we get 50 as, remember, as the simple interest he gained. But we want the value of Zach's entire investment. So that means we're going to add the simple interest he gained to whatever he put in the bank at the beginning, which is 500. Okay, so that's going to be 500 plus 50, which is just 550. Okay, now we have someone else, Yasmin, invests 500, which is the same, at a rate of 1.8% per year compound interest. So it's not simple this time, it's compound interest. Okay, and calculate the value of Yasmin's investment at the end of 5 years. Again, it's the same thing, but except her thing is for compound interest. So the value for compound interest is that the entire amount in your bank, okay, not just the interest gain, but the entire amount in your bank is going to be equal to whatever you invest, okay, P, let's say, into 1 plus R, okay, and R being whatever you have in percent, by 100 to the power of n, which and n is like the number of years over here. So again, let's just substitute everything into the formula and we'll just get the value. So that's, in this case, it's going to be 500 into 1 plus, again, R is, this time it's 1.8%, 1.8 by 100, okay, to the power of, and how many years? 5 years, it's the same thing. So if you put that in your calculator, you should get 546.65. So 546.65. Okay, which is less than what Zach earned. Okay, so part 3. Zach and Yasmin continue with these investments. How many more complete years is it before the value of Yasmin's investment is greater than the value of Zach's investment? Okay, so firstly, we know at 5 years that Zach's is still greater than Yasmin's. Zach's is 550, and Yasmin's is less than that. Okay, so they want us to calculate in how many years does Yasmin's investment become greater than Zach's. So how we do this is we have to do trial and error. So let's make two things. One is for Yasmin and one is for Zach. So first, let's take a random number. Let's take 10 years, and let's calculate the value of both of their investment at 10 years. So Yasmin's investment would be 500 into 1 plus 1.28 divided by 100 to the power 10. Wait, let me just check. 1.8. Sorry, my bad. 1.8 by 100 to the power 10. And Zach's would be 500 into 10 into 2 divided by 100 plus his original, which was 500. So we calculate both of their investments after 10 years. Okay, we would get, for Yasmin, we would get, hold on, 500 into, remember to put, when you're doing this in your calculator, put the brackets and the fraction and everything, because you don't want it to go wrong. and like the brackets matter. Okay, so Yasmin's would be 597.6, something like that. And for Zach's, um, it would be it would be 600. So we can see over here that Zach's is still greater. Okay, so let's now we have to try. Let's try for a different amount of years. Let's try 11 years. Because we can see it's not that much greater. It's only like 3 greater. So we don't want to go too much higher number. So I'm deleting the working over here, but you should leave your working, and remember, ask for like an extra page if you need it, because um again, the examiner wants to see that you have all your working. Hold on. I'll just leave that part in. Okay. So now let's calculate for 11 years. For Yasmin, it's going to be 500 into 1 plus 1.8 divided by 100 to the power 11 instead of 10. And for Zach, it's going to be over here, we're just going to make this an 11. Yeah, so just put that in your calculator. Let me just take this out. Yeah, so now we'll try with 11. So if you put Yasmin's in your calculator, 500 into, and again, don't forget the brackets, 1.8 to the power 11. Remember to put everything in this whole part in the brackets for Yasmin. Okay, so we should get 608.4. Now, if you do Zach's in our calculator, 500 into 11 into 2 by 100, and then add that to 500, we get 610. So we can clearly see that it's not equal. Obviously, this is now 2 less. So let's take an even bigger number. Let's take 13. Wait, let's take 12, because just to be sure. Okay, changing these to 12. If you put 12 in your calculator, you should see that it's also not greater. So let's try 13 now. Sorry, my 13 over here. Okay, so we're just gonna put 13 in our calculator. And remember, again, make sure the examiner sees all your attempts, so he knows what you're doing. Okay, so if we so for Yasmin, if we put 13 in our calculator, 1 plus 1.8 by 100 to the power 13, we should get 630.5. 630.5. And for Zach, 500 into 13, 2 divided by 100 plus 500, we just get 630. So we can clearly see that 13 years, after 13 years is where Zach's is greater than Yasmin's. But remember, over here they're saying how many more complete years. So they want more years, right? And they don't want less years. Okay, I'm sorry, not yes, they don't want up to what we've already calculated, and what we've already calculated is after 5 years. After 5 years. Okay, but now we can see that after 13 years is when Zach's is when Yasmin becomes greater than Zach's. But we just want how many years after 5. So we're just gonna do 13 minus 5, which is 8. And that's our answer over here. 8 years. You don't have to write the unit, but just to be safe, 8 years. Okay. Part B. Xavier buys a car for $2,500, and the value of his car decreases exponentially at a rate of 10% each year. Okay, calculate the value of Xavier's car at the end of 5 years and give your answer correct to the nearest dollar. Okay, so we know that for exponential decrease, okay, we're just going to do the original amount, 2,500 into, okay, since it's a decrease and not increase, okay, it's going to be into 1 minus 10 by 100, again to the power how many years, and over here they've said 5 years, so to the power 5. So if we put that in our calculator, so it's the same formula as compound interest, except percentage increase would be plus 1 plus the ratio by 100. So if we write a general formula over here, it would be, again, the amount into 1 minus the rate, let's say, by 100 to the power n, which would be the number of years. Okay, so 2500 into 1 minus 10 by 100 to the power 5. Remember, again, you're doing the whole thing to the power 5. Okay, so if you put that in your calculator, you should get 1476.22. 476.22. And for this, we can just round it off to, since this is, we have a full number, we should leave it at 4 significant figures instead of 3, because again, it's there, it would be too inexact if we just said 1450. So we'll just take 14, sorry, my bad, I meant 1476, not 1446. Yeah, so $1476. Okay. Okay, part C, the number of certain type of bacteria increases exponentially. Again, it's exponentially at a rate of R% each day. Okay, after 22 days, the number of this bacteria has doubled, and they want us to find the value of R. Okay, so let's take the certain type of the number of initial bacteria as normal, and we know that, again, for exponential increase, okay, it's going to be a into 1, because it's increased, it will be 1 plus r by 100 to the power n, which is the number of, like, how many days or how many years it's increasing. In this case, it's 22. So a into 1 plus, wait, actually, let's not calculate that right now. Okay, so now we know that over here, we know we have the initial amount of bacteria. We're going to take this as the initial amount of bacteria. Okay, now they're saying after 22 days, the number of this bacteria has doubled. Okay, so that's going to be a, which is the initial amount, into 2. Okay, so now for these type of questions, okay, we need to make this into an equation and equate some stuff. So they're saying the number of bacteria has doubled. So we know that it's going to be 2a on one side of the equation. And we can equate that to whatever this thing over here that we've come up with. So we can say 2a equals to a into 1 plus r by 100 to the power over here 22, because it said that it doubles every the number is 22 over here. Okay, so, and it grows each day and after 22 days, so instead of years this will just be days, so that's 22. Okay, so now that we have this, don't get confused by, like, the lack of numbers. Firstly, we know over here it's not there are two multiplication signs on one side, so that means we can cancel out some stuff. So we can see that a occurs on both sides of the equation. So we can divide both sides by a, and we can get rid of this a. Okay, so now it's a lot simpler. We can rewrite this. 2 equals 1 plus r by 100 to the power 22. Now, again, how do we get rid of this exponent over here? All we have to do is take root 22 of both sides. Okay, so we can cancel out this exponent by rooting 2 by 22. Yeah. Okay, so now if you put that in your calculator, and don't forget, not just the square root, but remember to put the option in calculator that allows you to input the root. Whenever it's a 22nd root. So if you put that, you should get 1.032. So 1.032 and something else, of course, but I'm just going to ignore that, the rest of that value, equals 1 plus r by 100. And now we've taken out the square root, remember, by rooting both sides by 22. So we've crossed this out, and now we can just say it's equal to this. Now, again, of course, we just need to make r here the subject of the formula. So let me just clear up some space first of all. Okay, so now we have that this is equal to 1 plus r by 100. So now, draw an arrow. Okay, so of course we need to make r the subject of the formula. So first let's remember the rule of operation. So we can't take out 100 first, we have to take out 1 first because since it's at being divided by 100 and then being added to 1, we just subtract 1 away first. So it's going to be 1.032 minus 1 is going to give us r by 100. And now we just have our, again, we need to make r the subject of the formula. So to get rid of the 100 on the denominator, since it's being divided by 100, we're going to multiply both sides by 100. So there we have this as our final value of r. So you put that in your calculator, 1.032 minus 1, and then multiply that by 100. You should get 3.2, which is our value of r. And of course, it's three significant figures, so 3.20. Okay, now we have a graph, 5, 8. So it says 100 students each record the time, minutes, taken to eat a pizza, and the cumulative frequency graph shows the results. And they've shown us a graph over here. And so first they want us to find the estimate of the median. So we know that the median for cumulative frequency, remember, not for single, but I mean not for normal stem and leaf or anything, but for cumulative frequency, the median is going to happen at the frequency of the total by 2, just half the total frequency. So that, and since over here it's 100, see over here and over here at the top of the graph it's 100. So if we do 100 by 2, we get 50. So that's, as you can see on the graph over here, that's this point, the value right in between 60 and 40. So now let's take a line and let's draw a line all the way from, and use a scale in your exam and draw the line. So it comes exactly there. And now if we draw the line downwards, if we trace it back downwards, okay, so we can see it comes right over there at this point. So now, and remember, don't just say 50. It's not 50. It's the value at 50. So how do we know what value this is? We can see that in between 5 and 10, there's 1, 2, 3, 4, 5 main or, and we can also say there's each of these is 5, so 5 into 5 is 25. So there are 25 boxes between 5 and 10. And so to find the value of each box, we're just going to do 5 by 25. Okay, because that's 10 minus 5. So okay, so if we do that, 5 by 25, it's just 1 by 5, which is 0.2. So each box, one box on the x-axis equals 0.2. So now, and we also know that one main box is going to be 5, 6, 7, 8, 9, and 10. Okay, so now we can say 9.2 and 9.4. So that's where the median occurs. So we'll just write 9.4. 9.4. Okay, now they want us to find the interquartile range. So we know that the interquartile, wait, let me just take out this. Okay, so we know the interquartile range for any cumulative frequency graph is the values between 3/4 and 1/4. So the value occurring at 3/4 minus the value occurring at 1/4. Which is just, or you could just say 0.75 minus the value occurring at 0.25. Okay, so if we do 0.75 into 100, that's just 75. So over here on the y-axis, let's find the 75th value. So you know in between 180, this over here is going to be 70. Hold on, let me just lower my thickness. Okay. Okay, so we know that this value over here is 70, and again we can see that between seven sorry not seven my bad, this value over here between 60 and 80, this is 70. And we can also see between 60 and 70 there are five boxes on the graph. So that would mean and 60 and 70 is 10. So each box is going to be 10 by 5, which is 2 on the y-axis. Y-axis. Okay, so now this is 70 and we want 75. So 72, 74, and 75 is going to occur right in between 76 and 74. So now if you take a line, let me pin the line. Okay, now we just extrapolate it right from in between 74 and 76, and if we take it over here, now we draw down and we can clearly see that this is where it meets. So now what is that value on the x-axis? We know that that each box on the x-axis is 0.2, and we can clearly see this is two boxes after 10, so it's just going to be 10.4. So we know at the third 3/4 value is 10.4. And now let's calculate the value of 0.25, which is just 25. So on the y-axis, that would be over here is 20, and again 22, 24, and 25 would be right here. So if we draw a line, it intersects over here, and we can see that that is right at this point. So again, if we count what value this is on the x-axis, this is 5, this is 6, this is 7, and this is 8. So that's just going to be 8. We have 10.4 minus 8, and you could just put that in your calculator. 10.4 minus 8, and that is 2.4. So over here, the interquartile range is 2.4. Okay, part 3, the number of students taking more than 11 minutes to eat a pizza. Okay, so what does this mean? We want the number. So over here on the y-axis, we know that this is 11, 12, 13, and so on. And we want the number of students taking more than 11 minutes. So it's from 11 to 15. Okay, not including the exact value of 11. Okay, so now instead of using the values on the y-axis to find the values of the x-axis, we're going to calculate the value we need as the number of students which is on the y-axis, using the value on the x-axis. So first, we know that we want more than 11, so let's draw a line up from 11. Okay, place that exactly up, and use your scale and make sure this is accurate. Okay, it's somewhere over here. Now we take this value and extrapolate it, and we can clearly see over here that it's 80 plus 0.2, which is 80.2. Sorry, 82. 80 plus 2, which is 82. And we know 82 students are eating, have like 82 students have taken from 0 to 11 minutes to eat the pizza. And the rest of the students are taking more than 11 minutes. So what we do is, and we know there are 100 students in total. So that's just going to be 100 minus 82. And we put that in we put that in your calculator or do it mentally. 100 minus 82. It's 18. So that is our answer. Okay, B, it's a different set of students and a different type of, a different part. So they said 150 students each record how far they can throw a tennis ball, and the table shows the results. So here they've shown us the frequency and the distance that they throw the tennis ball. So 4 students can throw the tennis ball from 0 to 20 meters. 38 students can throw the tennis ball from 20 to 30 meters. 40 students can throw the tennis ball from 30 to 35 meters, and so on. You get the point, okay? So, and up to 60. So 60 is the max they can throw. So now they want us to find the estimate of the mean. So how do we calculate the mean? We know that it's just going to be the midpoint, okay, of x, which in this case is d, the distance. Okay, it's going to be the midpoint into the frequency. Okay, and we have to sum all of those. So the symbol for sum is sigma. Okay, this big thing over here. Okay, so it's just the sum of all the midpoints into the frequencies, and we divide that by the total frequency. The total frequency, which we can say is the sum of the frequencies. Okay, so how do we calculate that over here? First, let's find the midpoint for all of these distances. So that's just going to be the class width, which is the class width is nothing but the difference between the highest and the lowest number, and divide that and the just between those. Okay, the value right between those. So over here, we can see the class width is 20, and 20 by 2 is 10. So the midpoint over here would be 10. Okay, so let's just write all the midpoints above over here so we know what they are. Okay, for this one, we know that the values are from 20 to 30, and the midpoint from 20 to 30 is 25. If you're not really sure about this, you could always just do 20 by 30 minus 20 by 2 and just add that to 20, which would give you 25. And now over here, 30 to 35, you can see the class width is 5, and 5 by 2 is just 2.5. So that's just going to be 32.5. 32.5. Just increase the size of your pencil. Okay, now for the next one, it's 35 to 45. So again, that's just 10. The difference is just 10. And 10 by 2 is 5. So we just add 5 to 35, and we have the midpoint as 40. And lastly, 45 to 60. That's 15. The difference is 15. And 15 by 2 is 7.5. So 7.5 plus 45 is just going to give us 52.5. 52.5. And it's always best just put that in your calculator just to make sure you're not messing anything up. Okay, so now that we have these midpoints, we're just going to put everything back inside the formula. Okay, so over here we would say firstly it's we have the midpoint of 10, and the frequency over here is 4. So it's going to be 10 into 4. Okay, that's our first value. The second value is going to be, so we have to sum up all of these. So the sum of these plus the sum of these, and so on. So this one would be 25 into 38. Okay, and then this one over here would be, we calculate the midpoint to be 32.5. So it's 32.5 into 40. The next one over here, the midpoint is 40. So that's 40 into 53. Into 53. And my bad, there's a plus sign in between all of these. Okay, and the last one, the last midpoint is 52.5. And multiply that into 15 because that's the frequency. Now, the sum of all these values, we're going to add all of these values up in our calculator. We're going to divide that by the total frequency. We don't have to add up all these frequencies because they've already said that it's 150 students. But if you did add them all of these, you get 150. And if you put that in your calculator, don't forget the brackets in between all of these, and don't forget to add each thing separately. So be careful and recheck when you put in your calculator. Okay, but um you should get 34.65. So that is our answer over here, 34.65. And for the mean, when they ask you these type of questions and they want you to know the mean, remember we always put the full decimal places. We don't round it off unless it's a lot of decimal places, like more than 4 or 5. But over here we leave it as 34.65. Okay, part 2. A histogram is drawn to show this information, and the height of the bar representing 30, which is smaller than the distance. The distance is between 30 and 35. Over here, it'll be this distance. Just circle this distance. Okay, is 12 centimeters. Okay, and they've written it over here, and they want us to calculate the height of each of the other bars. So how do we do this? For this, since the frequency, since the class widths are different, as we've calculated over here, it's 20. Here it's 10. Here, for the first one it's 20. For the second one it's 10. For the third one it's 5. We can see the class widths are different. So that means that we can't just use the class widths in our calculation, the frequencies. We also have to calculate frequency density. And what is frequency density? It's nothing but the frequency divided by the class width. So we just have to calculate that for all of these. Okay, let's just make another um, column in our table. And just make the bars. This is just so you don't get confused by anything. Okay, so let's calculate all the frequency densities. Like the first one, we can see the class width is just 20 minus 0. So 20 by 4, which is 5. Around 5. The second one is 30 minus 20, which is 10. And, wait, sorry, my bad. It's not 5. Don't get confused over here. It's frequency by class width. So that would be 4 divided by 20. 4 divided by 20. And that is just 0.2. Okay. For this next one, it's going to be 30 divided by 30 minus 20, which is 3.8. Okay, for the next one, it's 40 divided by 35 minus 30, which is just 40 by 5, which is 8. Yeah. Okay, and for the next one, it's 53. 53 divided by 45 minus 35. And 45 minus 35 is like obviously in brackets, so which is just 10. So 53 divided by 10, which is 5.3. And lastly, the frequency 15 divided by the class width, 60 minus 45, which would just be 15 divided by 15, which is 1. Okay, so now that we have the frequency densities, we use these and the height of the bar to calculate the rest of the height of the bars. So all we need to do is calculate the ratio. So we know that the height of this bar, okay, so we know the frequency density of this bar is 8, okay, as we've calculated it. And we know 8 into some number is going to give us the height of the bar, which is 12. So to find this number over here, you could call this x if you want, but that's kind of confusing. That's just already multiplication sign. So anyway, to calculate this number, let's just make it the subject of the formula and divide both sides by 8. And 12 divided by 8 is nothing but 1.5. So that means that we're multiplying the frequency density divided into 1.5 to get the height of the bar. So let's do that for the rest of the frequency densities. So so just put these in your calculator. 0.2 into 1.5 is going to give you 0.3. Okay, 3.8 into 1.5 is going to give you 5.7. We can skip this one as it's already done. 5.3 into 1.5 is going to give you 7.95. And lastly, 1 into 1.5, which is just 1.5. Okay. Um. Okay. Yeah. So just make sure that you don't that when you're calculating the height of these bars, you use the frequency density, especially when the class widths are different. If the class widths are the same, you could just use no, you could just use the frequencies, but you should still calculate the frequency density just to be safe for everything. Okay. Uh, Now they've given us the same part, and it's a probability question. Two students are chosen at random. Find the probability that they both threw the ball more than 45 meters. Okay, so they both need to have thrown the ball more than 45 meters, and we know that the frequency of them throwing the ball more than 45 meters is 15. Okay, we also know the total number of students is 150. So total equals 150, and we know that out of 150, 15 of them do throw the ball more than 45. Okay, so what would be the probability of the first student throwing the ball more than 45? Would just be 15 by 150, because it's just the probability that any of these 15 students are chosen out of the total 150 students. Now for the second student, okay, we know that this student is already selected. One student is already selected. So there's one left in this category. So that's going to be 14 instead of 15. Okay? And we also know that there's one less total student. So it's going to be 149 instead of 150. So now we want the probability that 14 of them choose throw the ball 45 meters out of 149. So now if you put that in your calculator, um, you should get 7 by 745. And we can just leave this as a fraction, or you could just write it as a decimal value. But for probability questions, we can leave them as fractions. Okay, question 6, part A. So they've given us two vectors, P equals 2, 3, and Q equals -1 and 1. So what do these numbers mean? We know that this 2 on the top means that it's moved 2 in the x-axis, um, by 2 units in the x-axis, and we know this has moved 3 units up in the y-axis, and this is 2 units right in the x-axis. So if you drew the graph, it would move 2 in the x-axis and up 3 units in the y-axis, so it would be somewhere here. And Q has moved -1 units in the x-axis, which means it's gone to the left, and 1 unit up in the y-axis, which means it would be somewhere over here. So now, first they want us to find 3Q. So we know that for vectors, when we have to multiply, we multiply both the distance in the y-axis and the x-axis. So it's going to be 3 into -1 and 3 into 1. So that'll just be -3, 3. And remember, when you're writing these, it's not a fraction, so you can't divide anything. You can't say -3 by 3 is -1 and just write 1 -1. You have to leave it as -3 and 3. Okay, so now they want P minus Q. So that means, again, we have to subtract both the x, the x-axis and the y-axis. So it's going to be 2 minus, don't forget, this is a -1, not 2 minus 1, but 2 minus a -1. And in the y-axis, it'll be 3 minus 1. So now if you put this in your calculator or just do it manually, remember minus becomes a plus. So that will just be 3 and 2. Okay, so now they want us to find this is the sign. What is the sign? First of all, we know that when they add a vector like this, they want us to find the magnitude of the vector, which is the actual the actual distance. I mean the actual size of it, not just 2, 3 in bracket, not just like the y-axis and the x-axis. So we know the formula for this is going to be the root of the x coordinate squared plus the y coordinate squared. So again, essentially it's the same as the Pythagorean theorem. So you could always derive it, because technically a vector would just be a right angled triangle, this being the y coordinate and this being the x coordinate. I mean this being the y coordinate and this being the x coordinate. And if we wanted to find the hypotenuse, which would be in this case the magnitude of the vector, it's just going to be c squared, which is, let's take the hypotenuse, equals x squared plus y squared. And then c would just be the root of x squared plus y squared. Anyways, so if we calculate this, in this case, it's going to be root of 2 squared plus 3 squared. And if you put that in your calculator, or if you also know, the root of 2 squared plus 3 squared, which is going to be root 13. So if you write that as 3 decimal places, it's going to be three significant figures, 3.605, which rounds off to 3.61. Okay, part B. B is the point 2, 7, and vector AB. They've given us a new vector. Hold on. Vector AB is equal to -4, 6, and they want us to find the coordinates of A. So what does this mean? It means if this is the point A and this is the point B, this distance is nothing but, we should take it as, if this is the point B and this is the point A, then the distance between them is nothing but over here -4 and up 6. So this would be 6 and this would be -4. Okay, now they want us to find the coordinates of A. Okay, so we know the point of B. Okay, so this is 2, 7, and we also know that from A to B we're moving left 4 and up 6 as over here. So now what do we have to do to find A? We just have to find from B to A, right? So in that case, it's just going to be B minus the vector AB. Okay, so if we put that over here graphically, it's going to be 2, 7 minus -4 minus 6. Okay, don't forget the signs. So of course a minus and a minus is a plus, and that is going to give us 6 and 1. And if you write this is the x units and this the y units. So that will just become 6, 1. Okay, part C, it's a triangle, and they said that M is the midpoint of OH. So this is the midpoint of OH, and K divides GH in the ratio 5:2. So that means five parts and 2 parts. So the total is 7. So that's going to be, this much is 5/7 of GH, and from K to H is 2/7 of GH. Okay, now they said that OG is equal to G, so this is G, and OH is equal to H. And they want us to find MK in terms of G and H. Okay, and MK is nothing but from here to K. Okay, and they want to answer in the simplest form. So to find M to K, we also know that in vector terms, it would just be from here, from MH to HK. Okay, let's draw the arrows. From MH to HK, Or we could also say that it's from MO to OG to GK. Okay, but since the other way is shorter, let's just do this one from MH to HK. So in that case, we need to find both MH and HK. So first let's find MH. So the vector would just be MH plus HK to find M to K. So MH, what is MH? We know that OH is H and M is just halfway through. Okay, so that means O to M would be 1 by 2 OH, and M to H would be 1 by 2 OH again. So that means MH is nothing but half of OH, and we know OH is H. So that would just be half of H, which is H by 2. Okay, now let's find HK. Okay, to find HK, we need to know, first of all, what H to G is, because we know that H to K is just 2 by 7 of H to G. Okay, so what is H to G? Let's remove some of our confusing. Okay, so right, okay, so we know H to K, sorry, no, not H, let's say H to G first. So we know H to G is nothing but along this way from M to O and then O to G. And remember some H to O and O to G. So we know O to H is H. So in that case, H to O is going to be minus H. Okay? And don't mistake this for H. It's not the same thing because you're going backwards instead. Okay, so now what would be O to G? It's going to be, of course, minus G. Because again, we're going backwards. I'm sorry, no, it'd be plus G, my bad. Because we're not going backwards, we're just going from O to G. And of course, HG is nothing but HO plus OG, plus OG, which is minus H plus G. Now, what do we want? We want 2 by 7 of GH. 2 by 7 of GH. I mean, in this case, HG, because we want HK, not KH. Okay, so 2 by 7 of minus H plus G is going to give us HK. So now let's just expand out the brackets. So we know we have to multiply 2 by 7 into minus H and 2 by 7 into G. It's going to be minus 2 by 7H plus 2 by 7G. And now we know that MK is what they want us to find, MK. And we've already said that MK equals OM plus, not OM, MH plus HK. And here we have MH and we have HK. So let's just add them up. That's going to be H by 2 plus minus 2 by 7H plus 2 by 7G. So of course we know we can add the H terms because we can just think of them as the same terms, so we can add them. And in that case, it would just be 1 by 2H plus minus 2 by 7H, which would of course just be 1 by 2 minus 2 by 7 into H. So if you put on your calculator, 1 divided by 2 minus 2 divided by 7, you would get 3 by 14. That's going to give us 3 by 14H. Okay, plus 2 by 7G. And remember, okay, they've said they want these in the simplest form. So this is the simplest form. So we're just gonna leave it at this. Okay, and let's write that again in our brackets. In the blank where they want it to be written. Let's make the pencil a little thinner. And again, 3 by 14H plus 2 by 7G. Okay. Question 7. So they've given us a bunch of functions. And firstly, they've said find G of 1 by 2. So we know that to find g of 1 by 2, all we have to do is instead of g of x is g of 1 by 2, so that of course means we have to substitute 1 by 2 into the x part. Okay, so g of 1 by 2 is going to be instead of 2 by x, we're going to make it 2 by 1 by 2. And that is nothing, and that means, of course, if we have this, we just make this 2 into 2. Or you could put in your calculator if you're confused, and it would just give us 4. Okay, part 2, find hg of 1 by 2. So what does this mean? It means we're putting g of 1 by 2 we're putting this value, whatever we get for this, into the function of h. Okay, so, and we've already calculated g of 1 by 2. We know that it's 4. So we know that h of g of 1 by 2 is the same as h of 4, because we found g of 1 by 2 to be 4. So now h of 4 is just, again, let's put 4 into the x value of the h function. It's going to be 2 to the power 16. And this is just 16. If you don't have your powers memorized, you could always do it in the calculator. Part B, find x when f of x equals 7. Okay, so let's just plug in everything into the equation. We know f of x is 10 minus x. So 10 minus x equals 7. So now we just need to make x the subject of the formula. Okay, so let's move x to the other side and 7 to the other side. So since it's negative x, we'll add x to both sides and subtract 7 from both sides. So 10 minus 7 equals x. Okay, because we're just moving everything, and since 7 is positive, we make it negative on the other side, and x as well. So 10 minus 7 is 3, so x equals 3. So now part C, uh, find x when g of x equals h of 3. So we can just write down g of x first of all. We know g of x is just 2 by x. We know this is equal to h of 3. And of course, for h of 3, we just plug in 3 into the x value in h of x. So instead of 2 to the power x, it's 2 to the power 3. So now, if you do this mentally or put in your calculator, we know 2 to the power of 3 is 8. So 2 by x equals 8. Now, we just need to solve for x and make x the subject of the formula. So how do we do that? First, let's multiply both sides by x to get rid of x on the denominator. So 2 is going to equal to 8x. And now let's get rid of x on the numerator by dividing both sides by 8. So 2 by 8. And so we have x is equal to 2 by 8, which is the same as 1 by 4 if you simplify it. Or just put in the calculator and it will give you the simplified fraction. Okay, part D, find j inverse of x. So we know j of x is equal to 5 minus 2x. And to find the inverse, instead of j of x, we're going to write this as x. And instead of x, we're going to write this as y. Then we just solve for y. Okay, so let's rewrite that. So x instead of j of x is equal to 5 minus 2y. Now we just solve for y and make y the subject of the formula. So first, let's get rid of 5 by subtracting it from both sides. So x minus 5 equals negative 2y. And now let's get rid of the negative 2y. Since it's being multiplied into y, we divide it from both sides. So x minus 5 divided by negative 2. And remember, we don't want a negative 2 in the denominator, because that's not a rational fraction. So it always needs to be in the numerator. Okay, so that means we just have to make the numerator into negative x minus 5 and get rid of this negative in the denominator. So negative x minus 5 is nothing but, we can just switch around x minus 5 and make it 5 minus x. So 5 minus x is the same thing as negative x minus 5. Okay, so that will just be 5 minus x by 2. And so that is equal to y. And y is nothing but the j but j inverse of x. So we can rewrite that over here, 5 minus x by 2. Okay, part E, write f of x plus g of x plus 1 as a single fraction in its simplest form. Okay, so we know the value of f of x is 10 minus x. So let's just rewrite all of these terms in their actual in their functions. So that's 10 minus x, okay, plus g of x, and g of x is 2 by x, plus 2 by x, okay, and plus 1. And they want this as a single fraction. So we know that for adding fractions, they all need to have the same denominator. And over here, we can see only 2 by x has the denominator of x. So how do we make 10 by x and 1 the same denominator? We multiply them by x so that we can also put x on the denominator. Okay, so that means to make 10 minus x to have the denominator of x, we're just going to do 10 minus x into x by x. Okay, this plus 2 by x and plus 1 to make 1 with the denominator of x. It's going to be 1 into x divided by x. So now since they all have the same denominator, we can add up the fraction. We know to add them up, we just put the 1 denominator and just add up the numerator. Okay, so first let's simplify 10 minus x into x. So we know that x is going to multiply into minus x, and x is going to multiply into 10. So let's just write that over here. Okay, so we're just going to write that one simplified number. Okay, so 10 into x is 10x, and x into minus x is just minus x squared. Okay, so we have this plus 2 plus x. So now what are the similar terms? We can see 10x and x both have the term x, so that means we can add them in the same way we can add like 1 plus 2. So 10x plus x is nothing but 10 plus 1, which is 11. So it would just be 11x. Okay, so now let's rewrite this. So that's just going to be 11x minus x squared plus 2. And of course the denominator is x. Because when we add these fractions as well on the bottom, it's just going to be x. So you can rewrite that again in the blank. 11x minus x squared plus 2 by x. Okay. Part F, they've given us another thing, and they said it's equal to ax squared minus bx plus c. So don't get confused by this, okay? All we need to do is write it out. So first they've said f of x whole squared, okay? We know f of x is 10 minus x, okay? So all we have to do is 10 minus x and square the full thing. Okay, minus f of x. So what is f of x? We know we just have to put in f of x into f of x. Okay, so in that case, since f of x is 10 minus x, okay, we take 10 minus x to be our new x value. Okay, so and this is equal to our x1. Okay, and we need to put this inside 10 minus x. So that's going to become 10 minus, and instead in place of x, we write 10 minus x. So 10 minus x. Okay, and remember this is a full thing. Okay, and this is equal to ax squared plus bx plus c. Okay, so let's ignore that part for now and let's just expand the first part. Okay, so we know that for a minus b whole squared, it's just going to be equal to a squared plus b squared minus 2ab. So in this case, 10 squared is 100 plus b squared, which is just x squared, and minus 2ab. So that's going to be minus 2 into 10 into x, okay, which would just be minus 20x. Okay, now let's expand this part. So first, let's simplify in the individual bracket. Minus minus into 10 minus x. So we know that again this minus is nothing but minus 1 into these two numbers inside the bracket. So we can expand these like any normal bracket. Minus 1 into 10 plus minus 1 into minus x. So just this would be 10, and minus 1 into 10 is minus 10, and minus 1 into minus x is just plus x. Okay, so again we can straight up simplify this. We know 10 minus 10 just cancels out. We can just ignore that. And so this full bracket is just equal to x. But remember, they want minus x over here, okay? So we have this as minus x. So now we can also see that there are two x terms, minus 20x and minus x. We can simplify these. We know minus 20x minus x would just be minus 20 minus 1. So that's minus 21x. So if we rewrite this, 100 plus x squared minus 21x. Now remember, they want it in the format of ax squared plus bx plus c. That means x squared term needs to come first. Okay, so x squared, and the next term is bx, so that's minus 21x, and plus c, which is 100. Okay, so now we know since the x terms are the same, we have an x squared here and an x squared over here. We have an x over here and an x over here. We have a c over here, the term without the x and the term without the x. So now we know that a is just the term in front of x squared, which over here is nothing. So it's not 0, obviously, it's 1, because 0 into x squared would just be 0. So this is 1, a is 1. B is going to be the term in front of x, which we can see is minus 21, and c is the term without x, which is 100. Okay. Part G, find x when h inverse of x is equal to 10. Okay, so let's look at h inverse of x again. So we know h of x is 2 to the power x. Okay, so h of x equals 2 to the power x. So now to find h inverse of x, first let's put h of x into as x and write x as y. So that would be x equals 2 to the power y. And now how do we find what y is? We don't need to find what y is right now. First, let's just see what they're saying. They're saying h inverse of x equals 10. And we know that when we rearrange this formula, we're going to get y equals something. X and something with x and something with 2. Okay, so that means that in this case, where we've written it like this, h inverse of x is nothing but this y value. And we also know that they want us to find x when h inverse of x equals 10. So that means we just need to put in h inverse of x, we need to put in 10, which means in y we need to put in 10. So that means x is going to be equal to 2 to the power 10. And if you put that in your calculator, you should get 1024. Okay, question 8. So they've drawn a diagram, and it's a triangle ABC on horizontal ground. AC equals 15 meters, BC equals 8 meters, and AB equals 20 meters. BP and CQ are vertical poles of different height. And so that they've also drawn the right angles, so we know that they're parallel, like vertical and right angles. So BP equals 3 meters and CQ equals 4 meters. AP and PQ are straight wires. Show that angle ACB equals 117.5 degrees. So what is angle ACB? So it's this angle over here. So we know as we have three sides on this, let's redraw this triangle. Okay, A, C, B, and we know the value of each side. Sorry, and so we know that when we have the value of each side and we want to find an angle, we can use the cos rule. Okay, so in this case, okay, cos C, which is this point C, is going to be equal to a squared, which is the side next to c, plus b squared, which is the other side next to c, okay, minus c squared, which is the side which is opposite from the angle c, divided by 2a into b. So now we just need to plug everything into the formula. So cos c, which we don't know what c is yet, is equal to 15 squared. So 15 squared plus 8 squared minus 20 squared divided by 2 into 15 into 8. So if you put the top fraction in your calculator, and don't forget to use brackets wherever needed. Okay, 15 squared plus 8 squared minus 20 squared divided by 2 into 15 into 8. And you should get, uh, hold on. Okay, you should get a number. Uh, wait, my bad. Wait, 15 squared. Okay, yeah, you should get negative 0.4625. So don't be worried about the negative sign, okay? So now all we need to do is we know cos c is equal to this value. So c is just going to be equal to cos inverse of the value that we found. Let's say that's x. So just put cos inverse in your calculator and put in that value. And you should get 117.54. Just put it to do two decimal places. And now, since they're saying correct to one decimal place, you're going to show that you're rounding this value off to 117.5. Okay, part B, calculate the area of triangle ABC. So we know that the area formula for a triangle, when it's not a right angle triangle and we know two sides and the angle in between the sides. So let's say this side is C and this is A and this is B. Wait, let's just call this side A and this side B, lowercase b and lowercase a. We know that the area of the triangle is just going to be, according to the formula, it's going to be sine C into A into B into 1 by 2. Okay, so, and assuming that this is the angle in between sides A and B. So now we just need to put in the values of our triangle into that. So we know over C, we've calculated C to be 117.5. So it's going to be sine 117.5 into, and we know A over here is 15 and B is 8. So 15 into 8 into 1 by 2. So if you put that in your calculator, you should get 53.2. I mean, rounded off to two significant figures. Sorry, 53.2. Okay, calculate the length of AQ. So let's look at what AQ is over here. It's this side. And we can also see over here that AQC is a right angle triangle. Okay, and we know two of the sides, 4 and 15. So let's write that again. So this is A, this is Q, and um, this is Q, and this is C. And we know that AC is 15, and we also know that QC is, as it says, 4. It's 4. And we know that this angle here is a right angle. So we know according to SOHCAHTOA, we know that, And of course, we want this. I mean, no, we don't need to use SOHCAHTOA. We know this is a right angle triangle, so we can use Pythagoras theorem, and we know that a squared plus b squared equals c squared. And over here, and c squared is the hypotenuse. So over here, we do want the hypotenuse. So that's just going to be 15 squared plus 4 squared is equal to c squared. And of course, to get rid of the square root, we just have to root the other side. So that's just the root of 15 squared plus 4 squared. Okay, so if you put that in your calculator, you should get 15.52, which we're going to round off to three significant figures. 15.5. Okay, calculate the angle of elevation of Q from P. So the angle of elevation of Q from P. So let's draw a line over here, and we know that the angle of elevation. And let's hold on. Let's draw a line over here, and let's draw a line over here. So we know the angle of elevation is just going to be how much higher um, Q is from P. So in that case, it's going to be this angle. Hold on. Yeah, this angle. Okay. So that's the angle that Q needs to go down by to be on line QP. Or we could just say the angle. Yeah, okay. So now they want us to find that angle. So we can just make this into a right angle triangle. Or we also know that if we draw a line over here, this angle is 90. So we know that this angle which is going to be 90 minus this angle. So we can easily find this angle by drawing a triangle. Okay, so we have a triangle, and over here is going to be Q. This is going to be this line. So this is going to be our triangle. So we can call this C, even though it's not really C, because it's a little higher from C, and this is P. So we know the distance between C and from P is 8, because it's parallel to down here, which is 8. Okay, and we also know this is a right angle, and we also know that this is 4. Okay, so now we want to find this angle, and we're just going to do 90 minus this angle. Okay, so how do we find this angle? We know according to we know that tan theta is equal to opposite by adjacent, and over here the angle opposite from this angle that we want to calculate is 8. The side opposite from this angle is 8, and the adjacent side is 4. And you might be confused thinking, isn't the hypotenuse the adjacent side? But no, that's the hypotenuse, not the adjacent side. Okay, so now to find theta, since we know tan theta is 8 by 4 in this case, we know that theta is just going to be tan inverse of 8 by 4. So if you put that in your calculator, you should get 63.43 something. So now in your calculator, you're just going to put 90 minus the answer you got. Okay, minus this answer. And you should get 26.5. Wait, hold on. Wait, sorry. I'm messed up. This side over here isn't 4. It's we know that over here this is 3 meters, and since this is parallel, we know that this is going to be 4 minus 3. Hold on. So tan theta isn't 8 by 4, but because we know QC is going to be 4 minus 3. Because over here, let me just erase this to clear it up a little. Okay. So over here, we want this line. And we know this line is parallel to CB. And so if this is 3, this over here is also going to be 3. and since we want this top length, it's just going to be 4 minus 3. Okay, so now tan theta is going to be 8 divided by 1, which is 4 minus 3. So if we do inverse tan of 8, we're going to get 82.87. And now, of course, that's just going to give us this angle. But we want the angle of elevation, which is this angle. So we're just going to do 90 minus that. And just put 90 minus the answer in your calculator. And you should get 7.13 rounded off. Of course, with 3 significant figures. Okay, so they're saying a wire connects A to the midpoint of PQ. So wait, I'll just draw that with a straight line. So it's from here all the way to PQ, and this point over here in PQ is the midpoint. So this is the midpoint. So we know that the distance between this and this is equal, and we also know that the height over here will be half the height between 4 and 3, which is just 3.5. We can already say this height is 3.5 because it's right in between. Okay. So what is the angle between the wire and the horizontal ground? We need to make this a triangle, and so this is the angle we need to calculate. Okay, so how do we calculate that angle? We already have this height. We know it's 3.5. So all we need to find out now is this length. Sorry, there's an airplane. Yeah, so all we need to find is this length over here, between the triangle. So how do we find that? Like I said, we know we know that if this point is the midpoint between C and B, okay, and we know since CB is 8, that means it's going to equally divide CB into 4 and 4. So if we want to find the length between A and the midpoint of CB, we can draw another triangle. Okay, this is A and this is C, and this is the midpoint of CB. Okay, so we already know how much we already know AC is, one sec, let me get rid of all this. Yeah, 15 meters. We already know AC is 15 meters, so you know this much is 15. And we've already also calculated this angle, the angle ACB to be 117.5. It's 117.5. And we also know that this length is going to be 4 because the line between A to the midpoint of CB is to the midpoint, so it divides CB equally into 4 and 4. So we know that C to the midpoint is going to be 4. Okay, so now what do we do when we have two lengths and one angle? We use the cos rule. Okay, so we know that cos of this angle ACM is going to be equal to the side AC squared plus the other side next to the angle, which is CM squared, minus this. So let's just write down the formula over here. So cos 117.5 is going to be equal to AC squared, which is 15 squared, plus CM squared, which is 4 squared, minus the hypotenuse squared, which is what we want to calculate. So we'll just call that AM squared. Okay, and we're dividing that by 2 into 15 into 4. So now all we have to do is make AM the subject of the formula. So we can go about that easily. So first let's calculate the denominator. 2 into 15 into 4. So you put that in your calculator. It's 120. Cross that and write 120. Okay, and now let's calculate 15 squared plus 4 squared. We're just simplifying things a little bit. Okay, so put 15 squared plus 4 squared in your calculator. That's 241. We can write this as 241. Okay, now we have a little simplified formula. So let's get rid of the denominator by multiplying both sides by the denominator, which is 120. So 120 into cos 117.5 is going to give us 241 minus am squared. Now we want am to be the subject of the formula, right? Okay, so we're going to take am to the other side to get rid of the minus sign. Am squared equals, and we'll take 120 cos 117.5 to the other side because we want to isolate am. Okay, so that's going to be 241, and of course we have to subtract 120 as it's going to the other side, so it's going to become negative. So 120 cos 117.5. And now, of course, we want am, not am squared. So how do we get rid of the square? We square root both sides. We'll just draw a root, okay? And we can take out the square. Now, if you put that in your calculator, 241 minus 120 into cos 117.5. Okay, and then we take the root of that. We should get am equals to 17.21, something like that. You should get that similar to that number in your calculator. Okay, so now that we have that, now we have, so let's redraw the triangle to know what we need, right? We need the so we have this triangle, and this is A, and this over here is the midpoint of QP. Write that, midpoint QP, and this is the midpoint of CB. Okay, so we just calculated A to the midpoint of CB to be 17.21. Okay, and we want to find this angle, and we also know that we've said that from the midpoint of CB to the midpoint of QP, it's going to be 3.5 because Q to the bottom is 4 and P to the bottom is 3. So the midpoint is going to be the length right in between 4 and 3, which is 3.5. So we know this is 3.5. Okay, now we have the side adjacent to the angle and the side opposite to the angle. And so we know that tan theta equals adjacent, opposite by adjacent, O by A. So we know theta is going to be tan inverse of opposite by adjacent, and in this case that's 3.5 divided by 17.21. Okay, so if you put that in your calculator, you should get 11.49. 11.49, which we're going to round off to 3 significant figures, 11.5, which is our answer. Wait one sec. Let me just, wait, sorry, could you just, I just need to load the mark scheme. Wait, hold on. To just check my answers. Sorry. Okay, yeah, I'm continuing now. Okay, question 9A. So they've given us two rectangles, A and B, and they said the side of A is x, and the breadth of A is x, and the length is 3x plus 4. And for B, the length is, one of the sides is 2 and the other side is x minus 1. And they also said that the total of areas of the rectangles A and B is 20 centimeters squared, and they want us to show some equation. So what we need to do here, we need to equate the total areas of the rectangles to 20 centimeters squared. So we know that the area of a rectangle is B into A. And so the area of both of these rectangles combined is just going to be BA of one rectangle plus BA of the second rectangle. Say B dash A dash. Okay, so now let's find that. Okay, so we know the area of A is going to be x into 3x plus 4, and we're going to add that to the area of B, which is 2 into x minus 1. Okay, so now let's expand out the brackets by multiplying each term into the term outside the brackets. So x is going to multiply into 3x, and x is going to multiply into 4. So x into 3x is just going to be 3x squared, and x into 4 is just going to be 4x, so plus 4x. Plus, now let's multiply 2 into each of these terms inside the bracket, 2 into x and 2 into minus 1. So 2 into x will be 2x, and 2 into minus 1 will be minus 2. So now we can add the like terms. We know that 4x and 2x both are x terms, so we can add them, and 4 plus 2 is 6. So that means 4x plus 2x is 6x. So this will become 3x squared plus 6x minus 2. And, wait, hold on. Did I make a mistake? Um, Oh yeah, so now we have this, and we equate this to 20, which is our total area. Okay, so now that we have that, we need to show this equation that they're given over here, which clearly shows that there's the 0 on the other side. So that means let's subtract 20 from both sides to move 20 to the other side. So we're just going to subtract it from this other side. So that's going to become 3x squared plus 6x minus 2 minus 20, and minus 2 minus 20 is minus 22. So we can just rewrite this as 3x squared plus 6x minus 22 equals 0. Don't forget the 0 because minus 20 equals 0 because there is something on the other side of the equation. So now that we have this, which is of course the same thing that they've written, 3x squared plus 6x minus 22. So we've proven it. Okay, part 2, solve the equation 3x squared plus 6x minus 22 equals 0, giving your answers correct to 4 significant figures, and you must show all your working. So when they say this for solving quadratic equations, we know that before even if we do plug anything into the calculator, we need to show that we're using a formula to solve it. So, and we know that the formula for a quadratic equation is x equals minus b plus minus root of b squared minus 4ac divided by 2a. And this first term is a, the second term is b, and the third term, minus 22, is c. So now all we have to do is plug each of the values into the formula. Okay, so x equals minus b, so b is 6, so minus of b will be minus 6, plus minus the root of, so b is 6, so b squared will be 36. You could always put this in your calculator. And minus 4, okay, into a, and a we can see over here is 3, so into 3, into c, which we can see is minus 22. So into minus 22. And this divided by 2a. And we know a is 3, so 2a is going to be 2 into 3, which is 6. Okay, so now that we have this, we can put our original formula into our calculator to get our values, or we in the mode of quadratic equation, or we could just put this in our calculator for both the plus values and the negative values. But I think it's better um, to put this original equation into your calculator to make sure you're not making any mistakes. Okay, because this is sufficient working for for showing that you know how to solve the question. But okay, but now we'll just put our original equation into the calculator to double check. Okay, so we're going to say 3x plus 6 squared plus 6x minus 22, and you should get x equals minus 3 plus 5 root 3 divided by 3 as one of your answers. And the other answer, you should get minus 3 minus 5 root 3 by 3. So it's the same thing except plus 5 root 3 minus 5 root 3. Okay, so just check with this value that you've written over here, minus 6 plus minus this big one, and if you get the same values, then you know you've done it right. So now that we have those values, we can just simplify them. So minus 3 plus 5 root 3 divided by 3 is going to be 1.8867 something. Okay, and this other value over here, minus 3 minus 5 into root 3 divided by 3, is going to be minus 3.8867 something. Okay, so now remember, we need to round it off to three significant figures. So if you round off 1.88, it's going to be 1.89. And if we round off, if, yeah, sorry, we're not going to round this off to three significant figures because over here it says correct to four significant figures. So make sure you read the question. So four significant figures would be up to this 6. Okay, so 1.887, because 7 is greater than 5, so we round up, and minus 3.887. Okay, part 3, find the parameter of rectangle B. Okay, so let's go back up and see how rectangle B. So this is rectangle B, and they want this side plus this side. Let's take that out. So they want this side, this side, this side plus this side. So we can also say that's 2 into this side plus 2 into this side. Okay. So let's just draw rectangle B again over here, and we know that one side is 2 and the other is x minus 1. So this is x minus 1, this is 2. Okay, so what is it? And we know here now that we know what x is. It's either 1.887 or minus 3.88. 7. And we know that it obviously can't be a negative number because it's the length. So it has to be 1.887. So x minus 1 is just going to be 0.887. Okay, so now if we add them up, it's going to be 0.887 plus 0.887 plus 2 plus 2. So if you put that in your calculator, you should get 5.77 rounded off to three significant figures. So 5.77. Okay, so they've given us two rectangles, one with the height of capital H and length y minus 2, and they said the area is 15 centimeters squared, and the other rectangle has the length of just y and a height of small h, which is different than the bigger h. And they've also said that the capital H minus lowercase h equals 1. And they also said by forming a quadratic equation and factorizing, find the value of y. Okay, so that means in the quadratic equation we want all the terms to be y and none of the terms to be in terms of h. Okay, so first let's do what we did for the previous questions and equate the area to the length into the breadth. Okay, so we know area equals b into a. So for the first rectangle, that means h, hold on, 8 h into y minus 2 equals 15. Okay, and for the second rectangle, it just means lowercase h into y equals 20. Okay, so now let's rewrite both of let's rewrite the second equation, okay, in terms of y. So all we have to do is make y the subject of the formula. So we're just going to divide both sides by h. So y equals 20 by lowercase h. Okay, so now let's go back to the first equation where we have things in terms of capital H. Okay, so they've also said that capital H minus lowercase h equals 1. Okay, so to make capital H this one in terms of y, okay, all we have to do is first convert it to lowercase h, and then we can use this formula to convert it to y. Wait, let's actually put this second formula in terms of h. Okay, let's say, hold on. Okay, so we know h into y is 20. So let's put this in terms and write this in terms of y. We know that h is going smaller. H is wait, no, wait, my bad. Yeah, it is in terms of y. So we'll just leave it like this. 20 by y. So now we also know that capital H minus lowercase h equals 1. So how do we write capital H in terms of lowercase h? We just have to move this lowercase h to the other side. So that's capital H equals 1 plus lowercase h. Okay, so now that we know that this is what capital H is equal to, we can substitute this into our capital H in our original formula. Okay, so that's going to be 1 plus h into y minus 2 equals 15. And we also know that lowercase h is equal to 20 by y. So now we can substitute this back into our lowercase h. That's going to be 1 plus 20 by y into y minus 2 is equal to 15. Okay, so now first let's open up our brackets. Okay, so we know that when we have terms in the brackets, we need to multiply each term into each term. So that would be 1 into y and 1 into minus 2. Yeah, and 1 into minus 2. And also 20 by y into y and 20 by y into minus 2. So firstly, let's go one by one. 1 into y is just y. Now that plus 1 into minus 2 is against minus 2. Now 20 by y into y is going to be plus 20 by y into y on the top. And we know when there's a number that's also in the numerator that's also there in the denominator, we can cancel them out. So it'll become that. Okay, and just 20. And then we have 20 by y into minus 2 plus 20 into minus 2 by y. And this equals 15. Okay, so now let's simplify this a little. Firstly, we know minus 2 and 20 don't have any x terms, so we can add them. And 20 minus 2 is 18. So y minus 18. Okay, plus we also know that 20 into minus 2 is minus 40. So minus 40 by y equals 15. And now we can also take 15 to the other side. Okay, because it needs to be in terms of quadratic equation. So take it to the other side, it's going to become negative. So minus 15 equals 0. And again, we have minus 18 and minus 15, which are both non-x terms. So, and minus 15 minus 18 is just minus 33. So we have y minus 33 minus 40 by y equals 0. Okay, so now this doesn't look like a quadratic equation yet. Okay, but we also know, hold on, yeah, sorry, my bad, this is plus 18. Sorry, 20 minus 2 is 18, not minus 18. And so when we move minus 15 to the other side, that's going to be 18 minus 15, which is us 3. Okay, so now that we have this, it doesn't look like a quadratic equation. But remember, we need to get rid of this y on the denominator. So all we have to do is multiply each term into y. Okay, so y into y is going to be y squared. Okay, minus 3 into y will just be minus 3y. And if we multiply minus 40 by y into y, the y's are going to cancel out. It's just going to be minus 40. And of course, 0 into y is 0. Okay, so this is our quadratic equation. Now we need to factorize this. So how do we factorize this? We multiply the first term and the second term, a and c, and that's just 1 into minus 40. So ac equals minus 40. And now we need to split up our b term, minus 3y. Okay, we need to split this up so that when the two terms multiply, they equal minus 40 and they add up to minus 3. Okay, firstly, how do we go about this? We can just take any two random numbers that equal minus 3, or we can just take the multiples of minus 40. If we take the multiples of minus 40, there's minus 40 into 1. There's also minus 8 into 5. There's also minus 5 into 8. Okay, and so on, there are more, but we can also clearly see that from here, minus 40. So if we took minus 40 in 1, we'd have to do minus 40 plus 1, which would be minus 39, which is clearly not minus 3y. Minus 8 plus 5, however, would give us minus 3. Okay, so we can take these two terms, minus 8 and 5. Then if we split up the middle term, it's going to be y squared minus 8y plus 5y minus 40 equals 0. If you want to double check, hold on. Sorry, it's not minus. Wait, let me just. Yeah, so when we do 18 minus 15, that's 3, not minus 3. So that's plus 3y. So in that case, we take these terms instead. Minus 5 into 8 because, and if you want to recheck, minus 5 into 8 gives us minus 40, and minus 5 plus 8 gives us 3. So that will be y squared minus 5y plus 8y minus 40 equals 0. Okay, so now how do we factorize this? First, let's, hold on, let me clear some space. Okay. So first, let's take y out of the first two terms, okay? And then that's going to leave us with y minus 5. Because if you divide y squared by y, that's y, and minus 5y by y is minus 5. So now let's take 8 out of the second two terms because there's no y in the second term. So plus 8 into, and if we divide minus 8y, and we divide 8y by 8, that's just going to be y. And if we divide minus 40 by 8, that's going to be minus 5. Okay, so now we can see that y minus 5 is repeating. So that means we can write this as y minus 5 into this y plus 8. And so into y plus 8. And now we factorize, we know that y is going to be y minus 5, this term equals 0, and this term also equals 0. So that leaves us with y equals 5 and y equals negative 8. So now which value of y do we take? We know that y is going to be the length of something, so it obviously has to be positive. So that means it's just going to be 5. Okay, question 10, part A. So they've given us a curve and they've said the diagram shows a sketch of the graph y equals f of x for minus 1.5, for x greater than minus 1.5 to 6. Okay, the coordinates of the 5 points on the graph y equals f of x are shown in the diagram. And f of x equals k has two solutions in the interval minus 1.5 to 6. Write down a possible integer value of k. Okay, so we know that if so the line k is going to be a straight line because we know what f of x is also y, so that means it's going to be a straight line somewhere here or here or here and so on. Okay, so inside it has two solutions in the interval minus 1.5 to 6. Let's just get rid of this. So we know that means it has to intersect at least twice. It has to intersect only twice and exactly twice in the curve. Okay, so if we drew it over, if we drew our line over here, okay, we can clearly see it's intersecting we can 1, 2. Wait, hold on. Yeah, and clearly see it's intersecting 1, 2, and 3 times with the curve. So that means it has 3 solutions. So it can't be there. But we also know that from this value, it's okay. This value it clearly intersects only twice. Okay, 1 and 2. And if we extend the line, it doesn't intersect. So if we were to extend the line, it would be from here all the way to here, and so it doesn't intersect anywhere else. If we did take another possible scenario, we could also take somewhere along this point where it also does intersect twice. Okay, so we can take either this point, which we know is going to be lower than 5.5, because we know up here is 5.5 and it has to be lower than 5.5, otherwise it would intersect. It could it could be anywhere from 5.5 or below that, or we could just take the y coordinate of this point b, which is minus 1 comma 7. So let's just take that. You can take whichever one you like. And so over here we know b minus 1 comma 7, so we know the y coordinate is 7. So k is just the line y equals 7. 7. So you could take any solution you want as long as it does intersect twice. Okay, part 2. F of x equals j has no solutions in this interval, the same interval above, when j is smaller than a or j is greater than b. Find the maximum value of a and the minimum value of b. Okay, so let's look back at the graph and let's clear up our previous working. Okay. So we know that it has no, we don't want it to have any solutions. So we can clearly see over here, this full part over here, it has no solutions. And where it needs to be below to have no solutions is, it has to be below this line, because otherwise it would have one solution. Okay, so the maximum value it can be to have no solutions, okay, is y equals 3, because we know the y coordinate is 3 over here. So this line has to be at 3. Okay, so this is the max value it has to go for all the values of no solutions, it has to be below this value. Okay, so and also to have no solutions, it has to be above this value, the top of the curve. Okay, and since we can see over here they've written the y coordinate to be 10, it's going to be 10 over here. 10. This part is 10. Okay, so this line is 10 and it needs to be above that. So all the y values above that, it's going to have no solution. Okay, so that means it can't go below 10, which means the minimum equals y equals 10. Okay, so now they've said the maximum value of a, where j is smaller than a. So we know that it has to be this we've written is our maximum value, and all the y points will be below any of these points. It could be 2, it could be 1, it could be 0. So everything below a. So therefore a equals 3. Anything below 3, and b is going to be 10, and all the values above 10 will all our values above 10 won't have any solutions. Okay, part B, find the coordinates of the two stationary points on the graph of y equals x to the power 6 minus 6x to the power 5. You must show all your working. Okay, so we know that first to find the stationary points, we have to equate dy by dx to 0. Okay, so we means we have to differentiate this function. And to differentiate it, we know that for x to the power n, it's just going to be equal to n into x to the power n minus 1. So y equals x to the power 6 minus 6x to the power 5. So if we differentiate x to the power 6, that's going to be 6 into x to the power 6 minus 1. Okay, now minus our second term is 6x to the power 5. So, sorry, minus 6x to the power 5. So minus 6 into 5 is just minus 30, and x to the power 5 minus 1. So first, let's just simplify this. 6x to the power 6 minus 1 is just 6x to the power 5 minus 30x to the power 4. Okay, so we know that this is equal to 0. Okay, so now let's factorize out this equation. Okay, so we know that if we take x to the power 5, it's just going to be x in it's going to be x into x into x into x into x 5 times. X to the power 4 is going to be x into x into x into x. Okay, so that means if we take out x to the power 4, if we take that out, we're just going to be left with 1x. Okay, so that means if we factor out x to the power 4, okay, that's just going to be, it's going to become 6x, because x to the power 5 will only have 1 left from x remaining when we divide it by x to the power 4. Okay, minus 30, okay, equals 0. And this is going to be minus 30 because as depicted over here, we have no x's left when we divide when we divide x to the power 4 by x to the power 4. Okay, so now we can say that x to the power 4 equals 0 and 6x minus 30 equals 0. So if x to the power 4 equals 0, that also means that x equals 0. And if 6x minus 30 equals 0, all we need to do is make x the subject of the formula, right? So we take 30 to the other side. 6x equals 30. And again, we divide both sides by 6 to get rid of the 6. X equals 30 by 6, which equals to 5. Okay, so first we have our first coordinate of x as 0 and our second coordinate of x as 5. Now, what we have is our y coordinates. Remember, we just need to substitute back into our original equation, which is x to the power 6 minus 6x to the power 5. Okay, don't accidentally substitute it into your differentiated equation, because that won't give you the right answer. Okay, so first we'll just substitute 0 into x to the power 6 minus 6x to the power 5. It's going to be 0 to the power 6 minus 0 into minus 6. So that is just going to give us 0 because we're multiplying both the terms by 0. So that means our first coordinate is just going to be 0, comma 0. And our second coordinate, which needs to substitute 5 into both of the points, okay? So x to the power 6 minus 6, x to the power 5. So if we substitute 5 into these points, that will be 5 to the power 6 minus 6 into 5 to the power 5. So if you just put that in your calculator, 5 to the power 6 minus 6 into 5 to the power 5, you will get minus 3125. So that's our y coordinate for the second point. And if you just want to make sure, you can always go back. Wait, actually, yeah, you don't need to go back to the graph. But if you just do want to make sure, remember you can always just put in your calculator in the dy by dx button and recheck to make sure that it works. And that's it for today.
Thank you, Varshini, and thank you all for listening to the video. I hope you found it helpful and and it will help you to tackle this paper effectively. Goodbye, everyone, and don't forget to hit subscribe to stay tuned for more episodes coming in the way. Goodbye.